To calculate values for motion, we're not always going to have a graph, and we're just going to have a little story. And then you need to be able to use the equations of motion to calculate certain unknowns. Now, these equations of motion you will see are actually just derived from the graphs. So if you go and say the acceleration is the gradient of the graph, then remember it was acceleration is going to be your final velocity, or your y2 minus your initial velocity, so v minus u, over the time, which would be on your x-axis. And if you change this around, you can see that that brings you exactly to this equation. So you are lucky because someone did the maths for you to get to these equations, and you don't have to derive them ever. You just need to be able to use them. So it's basically back to primary school and word problems, because you're going to read the word problem, you're going to fill the right values into the right positions, and you're going to use your calculator to solve it. It's as simple as that. So you're going to look at a few examples of this. So now if you look at the equations here already, you will see that there are two different equations given to you on your information sheet. You can have equations that has V, U, A, T, and S, or you'll have the set of equations that has VF, VI, delta T, delta S, and also the A. I am going to use these variables for this video. You are welcome to use the others if you want. Different teachers like to use different ones. Luckily, we are able to use whatever we want, because on your information sheet for your matric exam, you will get both. I like these because you will see when you get to momentum later on, when you've got subscripts and subscripts and subscripts, it becomes a little bit too much. So I like using these. So for these values, we've used most of them already. You know that V is, or VF then, is our final velocity or our end velocity. All the velocities is going to be in meters per second. And remember, if it's something that's moving in a straight line, velocity and speed at a specific time will be exactly the same thing. Velocity is just the vector and speed is the scalar. Please keep that in the back of your mind. Then u is going to be our initial velocity or our starting velocity. You can use vi. A is our acceleration. T is the time. And S is the displacement. You've used all these values before. We are just going to look at a little bit more complicated situations, and we're going to solve these unknowns. Now, there are certain words that you have to look out for when you're reading these questions, and they are in your notes on page 221. So if you look at these different things, they say when the velocity and the acceleration is in the same direction, the object speeds up. That should make sense to you, because if I'm walking east and a force pushes me in the easterly direction, remember a net force causes acceleration. It means I'm going to speed up. And please don't say slow down in the westerly direction and then want us to think that you are talking about speeding up. Speak plain, simple English. Speeding up, slowing down, left, right, up, down when you answer these questions. Then when the velocity and acceleration is in the opposite direction, then the object will slow down. And again, if I'm walking east and something is pushing me west, the acceleration is going to be west, and therefore it's against my motion and I am going to be slowing down. Also, please think about these questions logically when you get them. When they say an object is starting from rest, then you know your initial velocity is 0. An object comes to rest or at a standstill, or read the questions nicely, then final velocity is 0. When we are dropping an object, now this is going to be more when we look at vertical motion later. Dropping means you are literally letting it go, and it means it starts at a velocity of 0. So that's also u0. Sometimes they're going to tell you an object is thrown down. If an object is thrown down, then it's not dropped, and then the initial velocity is not 0. Please read these words carefully. If an object is dropped from anything that is moving, you need to remember it is moving at the velocity of that object before it is dropped. Remember Newton's first law, you guys have done that now. An object will keep in its state of motion. So if an object is in a state of motion because it's in a vehicle, going up, down, left, right, doesn't matter. If it's in something and that something is moving and it leaves that something, it will be moving at that same velocity. Then the next thing that you need to remember is that time is a scalar. So if you end up with a negative answer for time, you need to remember, it's either happened before we started looking at the object, which is not relevant for our science that we do, or you've made a mistake in your question. So please, if you end up with a negative time, it means that somewhere you've swapped signs around. And I need to mention here that when we are working with equations of motion, remember we only work with pieces where the acceleration is constant. So if you are reading the question, you need to ask yourself, for this bit that I am working with, is the acceleration constant for that bit? And if the acceleration is constant, that also means that the force must be constant. So the F net must be constant and in the same direction as the acceleration. If there's now a force in the opposite direction, then something is wrong. And then you need a new set of information. So sometimes there's going to be three different things happening, and then you're just going to have three sets of information. But we're going to start by looking just at one set in the beginning. So you will see in your book on page 222, there is an example that there are actually two examples, and I'm going to quickly go through them to just explain this to you, and then I'm going to let you do some examples. So we're going to just use these variables and get used to using them. So in your book, it tells you that a motor car. Oh, wait, before we get there, I need to tell you something important. If we look at these equations, they actually make your life easy. Well, let's go back. These are the equations that you're going to get. V equals U plus AT. V squared equals U squared plus 2AS. And you can derive them all mathematically, but you don't have to. S is ut plus half at squared. Now you'll see in future I'm going to ignore this last one because I have seen too many times where this last one is used, people fill in the wrong values for u and v or the wrong signs, and they end up with very, very wrong answers. So if you can, try to avoid this last one. It's not taboo, and if you can use it correctly, you can use it, but rather stick to these three equations. You're never going to need this one. You can always use a combination of these to get this one anyway. So please rather stick to these, because now when you look at them, they make your life so easy. You can see that each of these, so the variables that we have is basically u vast. And you're going to see I'm going to write that down all the time, because when you start with an equation of motion question, you can basically read your question quickly, write this down, and when you read your question the second time, now after you've made sense of it, go and fill in your values in the correct places as you're reading the question. Now for this one, for these equations, what you will see now is in the first equation, v equals u plus at, there's one variable that is not there. So that is what I want you to look out for. Which variable is not there? So if you look at this equation, there is no s there. So if you go and write down all your information and you have no s, and it's also not what you're trying to work out, then it leads you to this equation. V is u plus at. I'm going to show you now in the example what I mean. In this equation, there is no t. So if the question doesn't give you a time and doesn't ask you for a time, then this one is not needed. Then it's going to lead you to that equation. And then the last one, this equation here, doesn't have a v in it. So if the question doesn't give you the final velocity and also doesn't ask you for the final velocity, then you're going to pick that equation. Like I said, I'm going to show you quickly how. The only thing now here is that initial velocity is in every single equation and acceleration is in every equation. Now remember, we said we work with constant acceleration, and that's why we need the acceleration. Initial velocity you can normally work out if you don't have it, by using one of the equations and then using another one. And you will see what I mean when we start calculating. Now, your first example on page 222 is a motor car starts from rest and it accelerates at 4 meters per second for 50 meters. What is the final velocity after it has traveled the 50 meters? Now you're just going to say, what are my variables? So UVAST. You've read your question fast and you have an idea now of what's going on in it. Please do that so that you know if something's going to change direction or something like that. Now we're reading it again. A motor car starts from rest. From rest means U is going to be 0 meters per second. Remember the forward slash is fine, just don't use a minus then as well. And it accelerates at 4 meters per second. So I know my acceleration is going to be 4 meters per second squared for 50 meters. So that is my displacement, 50 meters. What is the final velocity? So they're asking for the velocity after it traveled this 50 meters. Can you see time is not given and it's not asked? So we're actually not interested in the time at all. And remember, that leads us to that first equation there. V is U. Oh, I'm such a liar. That's not the one that doesn't have T in it. We need to choose the one that doesn't have T in it, which is the second one. V squared is equals U squared plus 2AS, if you look at what we did here. Now we're going to just write down the equation. Please write down the equation. I know some of you are very lazy to do that, but if all else fails, you will get a mark for that equation. So you're going to write down V squared equals U squared plus 2AS. That's your first tick. Please do not do the maths now. Fill in your values into the correct places first. V is what we want, so we don't know what it is. U we know is 0 plus 2. We have A is 4. Please be careful with the signs. The acceleration and the displacement is in the same direction here, so it's positives. In a simple question like this, it's fine. You can leave out the positives. But always think about things and the direction in which they are moving. S was given to us as 50. So now the rest is your calculator's problem. Don't waste too much time with the calculator. Do it in one step, and V is going to be 20 meters per second. You are all very good with your calculators. Now, if the question said that the motor car is going east, just remember that then you would have to say east here. The question gives you a direction, then you give a direction back because velocity is still a vector. There we go. That's the first example done. Then the second example is talking about a cyclist that is already traveling at 15 meters per second. He applies brakes, causing the bicycle to slow down with 5 meters per second per second squared acceleration, and it wants to know how long it takes to stop. Let's see. Same thing we're going to do. You're going to write vast. You can make up your own word. I really don't mind what you do. I'm just used to this one. And the order does not have to be this, but just write down your values. So they say he is traveling, or she, doesn't matter, at 15 meters per second. So that means the initial velocity when we start to look at her is 15 meters per second. The brakes are applied, causing her to slow down. So now you need to think, this slowing down means it's not in the same direction as the initial velocity. The force is applied against this motion. So therefore the acceleration is going to be minus 5 meters per second squared. And they're asking us, how long does it take to stop? So that's the only information we have. Now you had to read into this question that they're asking us for stopping. So if they say to stop, you should realize that the final velocity is then 0 meters per second. And the time is what they're asking us for. Now let's see on our equations, which one are we going to choose? We don't have S and we don't want to calculate S. So we're going to look for the equation that does not have an S in it. Let's go. V equals U plus AT. First mark we have. Once you have your information like this, your job's easy. So 0 equals 15 plus minus 5t, and then you go and work out your t. And please, if you did something wrong here, you're going to see, if you didn't put a negative with your in front of your acceleration, you would have ended up with a negative time. And that should show you that you've done something wrong. And then you must go and check your values. Your answers must be logical. We won't give you unrealistic answers. And there's our examples done. So now what I want you to do is to go and do example 11 on page 223, number A and B. And once you've done that, you can pause the video, go and do example 11, A and B, and then you can come back and quickly mark them. So to mark example 11, we're going to use exactly the method that you've just done. So I'm going to go a little bit quicker because I think you have this. I hope so. So again, you read your question fast. An aeroplane needs to reach a speed of 100 meters before it can take off. If its acceleration is 8 meters per second squared, calculate the length of the runway. So I am going to just use my UVAST again. Like I said, you can use anything you want. If an aeroplane starts, you must also read into the question. It's going to start from 0. They didn't tell you that explicitly, but if an aeroplane takes off, it is going to start at 0. And they tell us that it needs to read a velocity of 100 meters per second. Now, the acceleration is in the same direction as the velocity, so they're going to have the same sign. So we don't have to worry about pluses and minuses. 8 meters per second squared. You could put a plus in front of both of them. It really doesn't matter. The runway is what we want. Now here, T, not needed. So let's see which equation. So we're going to use that middle one. V squared equals U squared plus 2AS. And now it's plug and play. 100 squared equals 0 plus 2, and that's 8. Please get used to your calculator so that you don't waste time from year to year. It's really worth no marks whatsoever. And that gives us 625 meters. Again, displacement is also a vector. So if it was east or west, then you would have to put an east or west here. Example 11b. So make that also a little bit bigger. Now, the motorbike starts from rest. So I want a different color. Do UVAST again. Starts from rest. So this is going to be 0. It accelerates. So that's my acceleration. And it's in the same direction of the motion. So it's going to be positive. 6 meters per second. If acceleration and velocity is in the same direction, remember then the object speeds up. Meters per second squared for 4 seconds. Calculate the displacement of the motorbike. So this time, S is what we want. Now, V in this one, we don't want and we don't need. So V we can leave out. And that leads us to that equation there. There we go. So S equals UT plus half AT squared. Just for choosing the correct equation, we give you a mark. S is what we want. U we know is 0, so this whole piece falls away. Plus a half. A is 6. And T is 4. Please don't forget the squares. We see that way too often. And that gives me 48 meters. And that's your first practice done.